shearing forces are unaligned forces pushing one part of a body in one direction, and another part of the body in the opposite direction. When the forces are aligned into each other, they are called compression forces. An example is a deck of cards being pushed one way on the top, and the other at the bottom, causing the cards to slide. Another example is when wind blows at the side of a peaked roof of a home, the side walls experience a force at their top pushing in the direction of the wind, and their bottom in the opposite direction, from the ground or foundation. William A. Nash defines shear force in terms of planes. If a plane is passed through a body, a force acting along this plane is called a shear force or shearing force. Shear force of steel and bolts. Here follows a short example of how to work out the shear force of a piece of steel. The factor of 0.6 used to change from tensile to shear force could vary from 0.58-0.62 and will depend on application. Steel called En8 bright has ampere of 800 and mild steel has ampere of 400. To work out the force to shear a 25 ohm diameter round steel En8 bright. Area of the 25 mm round steel NM2 equals 12.52 I euro equals 490.8 mm 2, 0.8 kilonewtons per millimeter 2 x 490.8 mm 2 equals 392.64 kilonewtons equals 40 ton x 0.6 equals 24 ton. When working with a bolted joint, the strength comes from friction between the materials bolted together. Bolts are correctly torqued to maintain the friction. The shear force only becomes relevant when the bolts are not torqued. A bolt with property class 12.9 has a tensile strength of 1200 MPa or 1.2 a kilonewton per millimeter 2 and the proof load is 900 MPa equals 0.9 a kilonewton per millimeter 2. A bolt with property class 4.6 has a tensile strength of 400 MPa or 0.4 a kilonewton per millimeter 2 and the proof load is 600 MPa equals 0.6 a kilonewton per millimeter 2. Shear force equals the force applied tangentially to a body is known as shear force. References